Hi, and welcome to the frictionless incline ramp video tutorial. Here we have a 15 kilogram block on a 30-degree incline, and we're going to solve for the acceleration of that block. First thing to do is establish what forces are actually acting on the block. Well, we've got the force of gravity pointing down towards the center of the earth, and we have the ramp pushing up at an angle 90 degrees out of the surface of the ramp, and that is our normal force. There is no force pointing in this direction because there is no object pushing or pulling the block in that direction. So that force does not exist. We're going to drag these forces down to create our free body diagram. And we'll make force gravity a little bit smaller. And we're also going to take a moment to notice what direction the block is accelerating in. So the block is accelerating at this direction here, kind of down and to the left, and we're going to add this into our free body diagram. Please notice this is not a force, this is simply the direction of movement of the block. So because the block is not accelerating perfectly left and right or up and down, this is going to create a problem. If we were to take our normal force here and take the components of that to try to establish the acceleration of the block, this would be the x component. And if you notice, this x component doesn't actually land on the line of movement, so this is not going to work. The way we're going to solve this problem is we're going to rotate our system so that the direction of movement is perfectly horizontal. Oops, and put it back. Got to be just right. Alright, so now the direction of movement is perfectly horizontal. So this shows us that force of gravity is going to be the vector that actually is going to get broken into components, as now the normal force points straight up. So let's go ahead and put those components in. So we have the y component pointing down, and we're going to make sure that's a dashed line so we know that's a component and not a vector on its own. And we have the x component pointing to the left, and we're going to dash that as well. Okay, so we're going to use this free body diagram to create our force equations. So first we're going to start with the sum of all forces in the y direction. So the up forces, well, Fn is pointing up, so it is positive, and we're going to subtract the down forces, and this is the y component of the force of gravity. We can also formulate our sum of all forces in the x direction equation. So we've got this force here, this is the x component of Fg, so that's going to be negative because it's pointing to the left, and well, there are no forces pointing to the right, so that's it. The block is not accelerating up or down, so that means that this equation is equal to 0. The block is accelerating to the left or right, so that means that our x equation is going to be equal to mass times acceleration. Okay. We're going to be solving this equation because this is the equation that has acceleration in it. We are not going to be using this equation because we're not solving for Fn, and it doesn't really help us to solve for this equation. If we were solving for Fn, we would use the top equation. So that means that we're going to need this. We're going to need the force of gravity x component, which is this vector here. This vector is the same as this vector. And here is the triangle that we're going to be using. So in order to solve for this side, we're going to need this side and this angle. Well, this side is simply the force of gravity, so we can solve for that pretty easily. Force of gravity is equal to mass times 9.8, and the mass is 15 kilograms, so that makes this 147 newtons. And now what we're going to need is we're going to need this angle. So this ramp was brought down 30 degrees because the entire system was rotated 30 degrees, which means that force of gravity, which used to point straight down, or right here, was rotated over 30 degrees along with everything else. That means that this interior angle here is 30 degrees. So Fg in the x direction is equal to Fg times, well, this is an opposite side to the angle we're using, so that makes that sine of 30 degrees, which is the angle we're using. FG is 147, and the sine of 30 is 0.5, so that means that those multiplied together are 73.5 newtons. So we can just plug this into our X force formula, and so we have negative 73.5 newtons is equal to 15 kilograms times A. So let's see, 73.5 divided by 15 is acceleration. We're going to make that a lowercase acceleration. Acceleration is equal to negative 4.9 meters per second squared. Thank you for watching the frictionless incline ramp video tutorial.